Section 1.5, Shifting, Reflecting, and Stretching Graphs. Now I like to think of these things as having two separate effects, those that affect the input and those that affect the output. So what I'm going to assume is I'm going to assume that I'm given some graph y equals some f of x, and I'm given some positive number, a greater than 0. If I take my original function and I add a to it, this shifts the graph up, right? So things happen higher. So if I add 1 to it, if something happened at 0, it now happens at 1. If something happens at 3, it now happens at 4. If I subtract a, well, that shifts the graph down, right? So things happen lower. Now, I can also scale my function. Right? If I multiply my function by an a, it's either going to shrink it if a is less than 1, or grow it if a is greater than 1, right? So this will make the function do the same things it did. It'll simply make them more if we are shrinking it, if we are growing it by something greater than 1. Or things will happen less if we multiply it by something less than 1. If we multiply it by a half, we're going to get half as much output as input. If in addition, right, we scale it by a negative a, right, this takes something that is above the x-axis and moves it below, takes something that is below and moves it above. So that flips it across our x-axis, and it's going to scale it as well, right? So things happen opposite, more if a is greater than 1, and it's going to be opposite and less if it's less than 1. So that's what's going to happen to the outputs. Now what happens if we modify the inputs? Right? So given the same function and some positive number, if we add an a to that input, this shifts the graph to the left. Right? We are adding something to the input which makes things happen sooner, right? So if I have a graph, adding a is going to make things happen sooner, right? So if something happened at 0 here, that is going to happen at negative a here, because negative a plus a is going to be the 0. So the 0 is going to have to shift to the left. So things happen sooner if we add to our inputs. If we subtract from our inputs, well, that's going to shift things to the right. Things are going to happen later, right? We are delaying it by a. The negative a means we are delaying things, so things are going to happen later. Okay? By scaling our input by this a, we're essentially going to expand it or compress it around 0. If we have our function, if we have a square like this, by doing a 2x, right, that means things are going to happen twice as fast, and so we're going to get something that is a little pinched in, right? Things are going to compress, things are going to happen faster if a is greater than 0, or it's going to be slower if a is less than 1, right? So if a is a half, things are going to happen slower. Things are going to happen half as fast. Okay? Negative ax is going to flip it across the y-axis and either compress or expand. Okay, so if we had a nice cubic, something like that, okay, the negative is going to flip it across, and we can then scale that as well. Okay, so it's going to flip it left to right. All right, so let's take a look at an example of a parabola. Okay, so if we start with our base function x squared, doing an x squared minus 3 just takes our original function and shifts everything down, right? So instead of stuff happening at 0, it happens at minus 3. Instead of stuff happening at 1, 1 minus 3 is minus 2. Okay, at 2 we'd be up here at 4. 4 minus 3 is 1. So everything shifts down uniformly by 3 by subtracting a 3 from it. So this is a change in the output. We're just shifting stuff in the y direction. Okay, x plus 2 squared, this plus 2 means things happen 2 units faster. So things shift negatively in 2 by 2, right? So instead of happening at 1 here, instead of happening at -1, it now happens at -3. Instead of happening at about, what, 1.5, right? It's going to happen at -0.5. Okay, so stuff shifts to the left. Okay, stuff happens sooner. If stuff happens sooner, it shifts to the left. Okay, so that's a change in the input. Okay, this 1/2 x, this is a change in the output again, right? Instead of something happening at 1, it now happens at half. Instead of something happening at 4, it now happens at 2. Stuff that happens at 0 is still going to stay at 0, right? So again, right, instead of something happening at 4, it gets shrunk down to 2. Instead of 1, it gets shrunk to a half. Instead of 1.5, instead of something happening at 2, it now happens at 1. 2 happens at 1. So this is scaling, shrinking. Okay. All right. So this does flipping and scaling, right? So instead of happening at 1, right, it's going to happen at -2, right? If this distance was 1, right, this distance is 2, and it's on the other side. Instead of happening at 2, it's now going to happen way down here at -4. Again, the 0 stays at the 0. Okay? All right, so that's how to handle each of these pieces. Now, if we want to construct something like this, what we do is we first look and see, okay, our base action is the square root. So let's map that and see what, okay. So our base, our square root of x, it's a classic square root. A slide disappeared on me here, right? So this has two things happening, right? This has first our shift to the right, so it's taken our original parabola, or it's our square root, and it's shifted it 2 to the right, so everything happens 2 units later. Okay, modulo my ability to draw, of course. And then we scale it, so instead of something happening at 1, it now happens at 2. Instead of something happening at 2, it now happens at 4. Okay, so we have the shift and we have the scale, and then we're going to shift it in the y direction. We're going to shift this thing down by 3. Right? And that gives our final result. We take our scaled and shifted to the right object, and now we're going to scale it down. We're going to shift it down by 3 units. Everything moves 3 units down, giving us our final result. Okay, let's do another example. Hopefully I haven't lost any slides. Okay. All right, so for this example, we're given 1 over -2x plus 3. The basic action is this 1 over x. 1 over x looks like this. Right? As x goes to 0 from the positive side, we go off to positive infinity. As x goes off to positive infinity, it goes to 0. As x goes to negative infinity, it goes to 0. As x goes to 0 from the left, we go off to negative infinity. Okay? Now, the first thing I'm going to want to do is I'm going to want to flip this thing from 1 over x to 1 over negative x. Okay, so the green has taken our object and flipped it across the x-axis. Everything that happened on one side now happens on the other. I mean, do that properly, right? Instead of happening on the negative side, things now happen on the positive side. Instead of happening at -3, things happen at +3. Instead of happening at +1, it happens at -1, like that. Okay? So we've flipped this thing across the y-axis. Right. The next thing we want to do is we want to compress. Okay, so we take our function 1 over -x and compress it around the x-axis. Instead of something happening at 1, it now happens at 1/2. Instead of something happening at 2, it now happens at 1. Instead of something happening at 4, it now happens at 2. Okay? All right, so we have this compression toward the origin, right? Right? This +2 means that we are compressing things towards the origin. And then the last thing we want to do is we want to shift this whole thing up by 3. Okay, so instead of something happening at 1, it now happens at 4. Instead of something happening at -1, it now happens at 2. Right? Instead of something happening just below 0, it now happens just below 3. Just above 0 becomes just above 3, leading to our final result. Okay, there will be a bunch of examples coming out of this. Please look at them. Do your homework, keep working, keep learning, keep reaching for the stars.